Let's discuss today about divide and conquer algorithm. Yeah. So for solving this algorithm, we follow a strategy, a steps to solve this algorithm so that we get the desired output. So firstly, we break the problem into small sub-problems. So for example, if we take 2, 3, 1, 4, it's an array. If when when we have given this array, we'll just break into small sub-problems. So it is consisting of 4 numbers. So let's break into 2 parts. 2, 3 is one part. 1, 4 is another part. Okay, so we successfully got 2 parts. So solving those sub problems. Okay, when we got these sub problems, we'll solve it again and we'll divide it again into the smaller sub problems so that we can get the desired output easily. So again dividing it 2, 3, and for this one it will be 1, and this one it will be 4. Okay, so combining them, and last one is the combining them to get desired output. So when we combine those, we combine them in a sorter manner so that we get the solution in array sorter way. So 1, 2, 3, 4. So this is a process for a divide and conquer algorithm. As I already said you, divide and conquer majorly works in 3 parts. Divide, okay, conquer, and combine. So these are the main 3 steps. We perform this algorithm in recursion manner. So now I'm briefly explaining how this divide and conquer algorithms work. So for example, let's take an array of 7, 6, 1, 5, 4, 3. Okay. So as you can see, it's a 6-digit unsorted array. So when we divide it, so firstly we'll divide it. Okay. When we divide it, we'll divide it into 3 parts and 3 into 3. Okay. 7, 6, 1. Okay. And 5, 4, 3. Okay. So when we divide in these 2 parts, okay, we got what is the first point? The first point is we divide the main problem into the sub problem. Okay. So for 7, 6, 1, we certainly divide the sub problems. Until we get a single digit sub problems. Okay. So again dividing it into 7, 6, and 1, 5, 4, and 3. Okay. When we got this one, we got 2 single digit numbers. But what about this 4 one? So we'll again divide it until their single number digit. So 7, 6, 1, 5, 4, 3. We want the output in a sorted array way. In sorted manner. So when we sort this into, so we can see 1 coming out first, 3 coming out first because those are the first win, 4 and 5 and 6, 7. So 1, 3, 4, 5, 6, 7. So let's talk about the time complexity of this divide and conquer method. Okay. Time complexity. It is basically calculated by using Master's theorem, which is a very important theorem. Okay, please mind about the handwriting. Okay. So basically T, and this formula is T n A T n by A plus f of n. So What is n in this one? N is size of input. Okay. A is A, size of sub problems. A is size of sub problems, or we can say number of sub problems in our question. Number of. Okay. So what is n by b? N by b is size of each subproblem defined. Each subproblem. It is the size of each defined subproblem. N by b. N by b. So what is f of n? Finally, we coming to the f of n. F of n is the work done. F of n is a work done outside the recursive call. Okay. So basically, I said this algorithm usually works in a recursion. So f of n is a sum, or we can say f of n is a part in which the work done out of recursive call is calculated. So let's see implementation of divide and conquer algorithm. So in the implementation of divide and conquer algorithm, what is the main function we use in our code to let this array solve? So let's do it in Java, because Java is a simple program. I mean, not simple, but it can be understandable by more person. So when you given in a function if start and so this is our first if statement. We give if statement, we give else statement, and we close this. Okay. So basically, when I said first the what are the three processes of the divide and conquer? First, it's divide, conquer. I mean, taking place. Divide, conquer, and combine. So following these three steps, we wrote the code for the main function for the implementation of divide and conquer algorithm. So middle, as I said, middle equal to start plus n divided by 2. So basically, when we have an array 2 by 3, we firstly divide it. So by using this one, we firstly divide this 1 2 3 4 into 2. Okay. So first step, divide is over. For the conquer one, if the demo start A, this A is usually given as we can say as output, input, demo A, start, middle. So in this one, we'll just see the starting element and what is the middle element of in this insert a box. Okay, 1, 2, and the next process we divide A, middle, and start, N. So in the next one, we just see the middle one and the ending one of this one. So middle one, ending one. So by up to this process, we get 1, 2 divided into a certain one, and in a 3, 4 get divided into a certain one. So what are the advantages of this divide and conquer algorithm? Advantages. So firstly, the major advantages of this is we can solve the large and difficult problems, because if we have a conceptual question, it might be tough for students to solve this one. So when we use this divide and conquer algorithm, it is much appreciated to use this divide and conquer algorithm to solve larger problems like conceptual one. And second advantage is algorithm efficiency. Algorithm efficiency. Yeah. Why algorithm efficiency is a major advantage of the divide and conquer. The main part into two subparts, and those subparts will get solved to get combined in the last one and to get the desired output once again. Parallelism. Okay. We can use it in multiple languages. The next one will be memory access. Round of control. Yeah, basically, many students face round of issues. So, what are the applications of divide and conquer algorithm? In which processes, or in which sorting, or in which matrix manipulation, or in which algorithms the divide and conquer algorithm plays a major part. So, applications of DAC, divide and conquer. Okay. Firstly, merge sort. Because merge sort does the work for the divide and conquer algorithm because it's the main process in which we get the result output. Second is the quick sort. And thirdly is the binary search. Fourth is Strasson's matrix multiplication. It's one of the mostly used. And Katsuruba and sorry, Karatsuba algorithm. Yes. So these are the mostly used applications of divide and conquer, in which merge sort is a very useful one for the divide and conquer application. Binary search, quick sort, Strasson's matrix multiplication algorithm is all used, and it usually plays a very important part in getting these things done. So thank you for watching this video.